The question, is water wet, may seem like it has an obvious answer, but the science of it isn't that simple. Water is actually really weird, like way weirder than you probably realize, and our understanding of it may only just be coming to a boil. Water may not actually be just water at all. It has at least 66 properties that make it really different from most other liquids. Like, water has a higher surface tension than almost any other liquid. More solids dissolve in water than any other substance, and water is almost the only liquid in the universe where the solid form is less dense than the liquid form. That's why ice floats. All of water's weirdness has made life on Earth possible, and its extraordinary characteristics come down to one simple bond: the hydrogen bond. We all know water consists of one oxygen atom bonded to two hydrogen atoms. Because of the way the shared electrons side with that larger, more electronegative oxygen atom, water becomes a polar molecule. The oxygen end is negative, while the hydrogen end is positive. And this is essential. Water's polarity dictates how it interacts with absolutely everything, including all of the cellular machinery that drives life. But perhaps most importantly, also determines how water interacts with itself. See, when you have two water molecules next to each other, their opposite ends attract, just like magnets. The bond that forms between water molecules is called a hydrogen bond, and it's relatively weak, but it's what keeps water, water. At ambient conditions on Earth's surface, water should actually be a gas. Instead, the hydrogen bonds between the molecules makes water sticky, keeping it in liquid form. And something super wild happens when you take water down to really low temperatures. If it's pure water, there won't be anything to seed ice crystals, so it won't actually freeze into a solid. Instead, it becomes supercooled water. At a certain point in supercooling, research has let us see water as two different kinds of liquids. This is experimental evidence of something called the two-state model of liquid water. This is mind-blowing, I know, but try to picture all of those polar molecules in a glass of water. Their hydrogen bonds orient them toward each other in a specific way, but some of the molecules will get left out of those more orderly, lower density groups and are forced to just kind of cram together in a way that messes with their hydrogen bonds in higher density groups. A researcher in the field has a great way of describing this when he says, "Water is not a complicated liquid, but two simple liquids with a complicated relationship." The two-state model of liquid water is something we've been able to model with computers for decades, but it was extraordinarily difficult to observe until Anders Nielsen and his team were able to get a closer look in 2017. The team injected micrometer-scale water droplets into a vacuum to get them super cold super fast, and then used an X-ray laser pulse to probe the water's molecular structure. The laser pulses were only quadrillionths of a second long, so the team could capture multiple frames, so to speak, and then see how the structure between molecules changed over time. Like, over the course of a microsecond. Their groundbreaking results provided evidence for the point at which water starts to behave more like one form than the other, called the Widom line. This doesn't mean water acts like this all the time, but this experimental observation of these two phases of water at supercooling may provide explanations for many of water's quirks, and could help us better understand important phenomena like the melting of sea ice or how to best desalinate water. And it's important to remember that the two-state model of liquid water is still not widely accepted. Some in the field are skeptical about these observations and say that for many reasons it just doesn't make sense. But Nielsen and his team are continuing to explore the behavior of water at even lower temperatures with even more exciting lasers. Because while water still may be the most abundant liquid on Earth, it's definitely the most bizarre. If you want more on wild states of matter, check out this video over here and make sure you keep coming back to Seeker to learn all kinds of surprising things you never knew about the world around us. If you want more on the latest breaking ice research, let us know down in the comments below, and as always, thanks so much for watching. I'll see you next time.